Now we're going to talk about quadratic equations. Quadratic equations. Now there's a lot to talk about quadratic equations. So let's go to our blackboard. So let me give you a proper definition first. Definition of quadratic equation, right? So what do we call quadratic equation? Quadratic equation is equation equivalent to one of the following form. It looks like ax squared plus bx plus c equal 0. And a, b, c, these should be real number. And we have one condition, a cannot be equal to 0. So, every time that we have condition like this, we should ask ourselves, why do we need this condition? I mean, what happens when a actually equal to 0? So, what do you think? What will happen when a equal to 0? Well, look at this given form. If this a equal to 0, what will happen to this a square, x squared term? Well, that's going to go to 0, and we do not want that. Quadratic equation, by definition, we have to have this x squared term, right? X squared term. Notice that we do not have any restriction for b and c, which also means b and c can be 0, can be 0. So, couple of examples that I give you. Examples of quadratic equation. Okay, so I guess one of the typical one could be like 2x squared plus 3x plus 5 equal 0. Now that's a nice, very general form of this, right? We have nice ABC, and that's considered as quadratic equation. Well, we could also have, say, x squared equals 0. How about that? Well, according to this definition, what's our a? Our a is 1. What's our b and c? Well, they are both 0. So, something like that would be perfectly fine. Quadratic equation, even though it looks, a little bit strange and it looks too simple. What about something like this? Minus x squared minus 5 equals 0. I mean, technically speaking, something like that can also be a quadratic equation, because look at the a should be minus 1. What about b? B should be 0 because we don't have x term. What about c? C should be negative 5. So, something like that would be a quadratic form. So, what do we call a quadratic equation in this form? What do we call this form? This is what we call the standard form. I mean, do we need to know that? Well, yes and no, right? Yes and no. I mean, it's good to know that the specific name for that term, this is called the standard form. So, let's go back to this point again. What they mean by they want to secure this x squared term. So this x squared term is the essence of quadratic equation. This is the essence. This is the main point. to be a quadratic equation, you must have x squared term, right? X squared term. So, in previous chapters we talked about linear equation, right? This is like a side note. Well, so linear equation was what? Linear equation was a straight line, right? Any linear equation is going to be a straight line. What about quadratic equation then? What about quadratic equation? Quadratic equation, when we graph it, it's going to be a curve, and it's going to be a U-shaped curve. Either looks like this, upward, or looks like this, downward. And we have a particular name for this type of U-shaped curve. This type of curve is called parabola, right? Parabola. So, later chapter we're gonna do a full investigation on quadratic equation and the general behavior and graph, all that. But since we introduced this quadratic equation, it's good to know the basic information about quadratic equation. Quadratic equation is going to be a curve, U-shaped curve, and either looks like this or this. Okay, so the typical type of question that they ask from this part would be a solving equation, right? So example, solve. So let's say x squared plus 5x equals 0, right? X squared plus 5x equals 0. Well, before we actually jump in and start to figure out this solution, let me give you a little bit of other background. So this, what we are looking for is this side should be equal to this side, right? That's what we are looking for. X squared plus 5x equals 0. That means this side should be equal to this side, which is 0. Now, and this is a quadratic equation, so we know it's going to be U-shaped curve. So graphically speaking, let's say this is x-axis, and since this is a U-shaped curve, this is going to be U-shaped curve that looks like this. And graphically speaking, this is like over generalization. It may be, again, later chapter we're going to do a full investigation, do a proper graph. But at this level, it's good to think of this as a U-shaped curve, and solution should be this point and this point. In this case, we do have two solutions, because we U-shaped curve with this x-axis line, then it's intersecting, it's crossing at 2 points. But you should also keep in mind it's possible to have, for example, the curve goes like this, right? Then where's the intersection with this line? There's no intersection. What does that mean? That means we have no solution. And it's also possible to have a U-shaped curve that looks like this and touching at only 1 point. In this case, we have only one solution, right? Now, I mentioned that we have two possible solutions. Now, if you actually take a look at this actual equation more carefully, then the equation itself also suggests that we might have two solutions. Now, where does what part of this equation is telling us that we can have possibly up to two solutions? Well, you guessed it right there. That two right there. That two suggests maximum number of solution, right? That two suggests that we have a maximum number of solutions. So, on a side note, let's say we have 3x to the fifth minus 4x to the cube plus 11x squared minus 14 equals 0. I just made it up, right? I just made it up. So, this is not quadratic equation, of course. What's the highest degree of this equation? Well, right there. This is degree 5 equation. So we can have maximum 5 solution for this equation. I mean, it doesn't guarantee, but we can have up to 5 solution. We can have up to 5 solution. Now, if this is x line, we have 1, 2, 3, 4, 5. We could have a line that looks like this. Then we have 5 solutions. But, for this. But we could also have a line that looks like this. Then we have only 1, 2, 3 solution. So this 5 suggests that we could have maximum 5 solution, but it doesn't guarantee. If it shapes like that, then it's going to be 5 solution. However, what it guarantees is 4 turns that this graph of this equation must have. So in this case, we have 1, 2, 3, 4 turns, right? For turning point. What about this one? 1, 2, 3, 4 turning point as well. So if it's 5, it must have 4 turns. I mean, same principle applied in here. Maximum number 2. How many turns? 2 minus 1, 1 turn. That's why it looks like a U-shaped curve. So, if we just go a little bit further on that, if we have like x to the cube, let's say 2x to the cube minus 4x squared plus 5 equals 0, something like that. Third degree, possible 3 solution. How many turns? 3 turns. So, 2 turns, right? 1 and 2 turns. Then it might have. So we have 1, 2, 3, up to 3. Right? Okay. If you do not fully understand this, that's okay. If you understand half, I think that's good. At least you have some background of what's coming and, better understanding of this quadratic equation and this U-shaped curve, right? All right, so let's get back to this actual equation. How do we actually solve this? Any suggestion? How do we actually solve this? Well, one of the simple way to solve this is factor this. So if we factor this, then we have common factor x, and x plus 5 equals 0. So I told you before, all these algebra chapters and all these topics, they assume that you know this factoring stuff. They assume, and I do too, in a way. I assume that you know this stuff, and when we do this type of factoring, that you know what to do. So if that's not you, you still have trouble factoring this, stop the video right now, go back to the factoring video and those textbook, then make sure that you actually understand and know how to factor this. Otherwise, we're studying quadratic equation, but you will not understand because you do not know factoring, right? That's very unfortunate thing. So make sure that you know the factoring before you actually tackle this. All right, so once you factor like this, now let's look at this factoring more closely. What does that really mean? What does that really mean? It means something like this. We have x times x plus 5, and result should be equal to 0. That's what it means, right? That's what we said. X times x plus 5 equal to 0. In multiplication, if either this or this, if one of them is 0, then answer should be 0. I mean, that's a basic principle of multiplication, right? If one of them is equal to 0, if you multiply and it becomes 0. So from here, when do we have this equal to 0? When x equal to 0, of course. And when do we get this equal to 0? Well, x equal negative. I mean, in case like that, it's easy to see. I mean, in some case, if you have number here and it gets a little bit messy, then you can just actually set it up equal to 0 and solve this. Move this to the other side, then x equal negative 5, just like that, so you can solve it like that. So how do we solve this? Well, we just did. Our solution is x equals 0 and x equal negative 5. Just like that. So even though this is quadratic equation, this is actually a factoring question, right? You can see that, right? Factoring question. So, those factoring question can look like this. Let's say the second example, 2x squared equal x plus 3. So, I mean, this is not the particularly the easiest form because it's not in standard form. All right, let's take the standard form again. What was the standard form? Standard form was this form, right? As you can see, the x is in the left-hand side. I mean, right-hand side. Everything else is in the left-hand side. So this form is not. But not to worry, we can change that to standard form by simply moving this and this and this side. So it'll be, oh, you know what? Shouldn't write equal. Those silence just distracted me. So this x and 3 should be moved to the other side. Remember, when we move a term across the equal sign, what happens? The sign change. So this nice plus x now become negative x. Nice plus 3, when we move, it's going to be negative 3 equals 0. All right, just let you know that I'm not in danger or anything. It was just a silent outside, just in case. Anyway, all right, so let's get back to this. Now this changed to this. Even though they look slightly different, they're actually the same thing. Right? So now we need to solve this. Now if you do remember and know how to do this, this was one of those AC method. Remember that AC method, right? That we used. So A times C. A is what? A is 2, C is negative 3. So 2 times negative 3, negative 6. What about B? B is negative 1, right in front of here. So I'm not going to explain that again. If you're not sure, go back to the previous the factoring lecture, and make sure you study that. So this should be the result of multiplication. This should be the result of addition. So what are those two number combinations that we are looking for? So it must be -3 and 2. Remember that I told you that when we have negative positive combination, it's a good idea to write the negative first, right? Okay, so the given equation now we can rewrite as 2x squared. Using these two numbers, we are going to split. We are going to split this using these two numbers, right? That's the deal. Okay, so now negative x now becomes negative 3x positive 2x. Negative 3 equal 0. Now, if you simplify this, what do you get? Negative 3x positive 2x? Well, that's negative x. So that's right, that's what we have here. So even though this looks a little bit different again, we are dealing with the same equation. Now we are going to group these two together, and factor whatever that we can. So from here, we can factor x out, then it's 2x minus 3. From here, we really cannot factor anything. So it'll be just 2x negative 3 equal 0. Okay, now as you can see, we have this and this in common. So we're going to factor out 2x minus 3 like that. So what's left behind from the first term? Of course, is this x. And the linking operation is going to be plus because that's plus. Now, what happened in here when we factor out the entire term? Does it disappear or? Yes, that's right, it becomes 1. Because we are looking at this in a way, this 1 times of this. That's how we're looking at it. So whenever that we factor out the whole thing, we still have this 1. I mean, when we factor it, when we multiply it back, we should have that place as well, right? So to hold that place, we need this 1 equal 0. I mean, if I just give you one more side note, let's say you have x squared plus x and factor it. Now I have x to factor. What's left behind? X. What about here? I factor the entire term, and that should be 1, right? So that when you multiply it back, you have x squared. When you multiply it back in here, you have x. So you need this 1 when you're factoring out the entire number or the term, right? Same principle here. So when do we get either this or this to be 0? I mean, that's our solution, right? So from here, I mean, this one is easy to see when x equals -1. This one, I mean, for some of us, it may not be that obvious. So let's see. 2x minus 3 equals 0. How do we solve this? Move that -3 to the other side, to x equals 3. Divide both sides by 2. So we have x equal 3 over 2. We have one solution there. What about from here? From here, we have x equal -1. Okay, so here's our two solution, just like that. Just like that. So, I mean, I gave you a very basic type of equation and very basic type of examples, but there's a lot more other example that you should also try using the basic same principle, right? Same principle. So you should definitely try a lot of examples, right, with this kind. Now, so this was solving quadratic equation using factoring technique. Now there's other technique that we can also use, and one of them is called the square root method. Right? So let's check out that technique. The square root method. So what's the square root method? Well, basically it looks like this. X squared equal p. When we have x squared equal p, and p must be greater or equal to 0, then answer is plus minus square root of p. Or sometimes people say just x equals square root of p and x equal negative square root of p. So they sometimes put it separately like that. Sometimes they combine it like that. Doesn't really matter, right? You can write it like that. You can write it like that. Okay, so this is the square root method. This is the square root method. I mean, if you have some background on what this square root means and all that, then you can actually derive this square root thing using the perfect square. However, we're not going to do that, but I am going to talk a little bit more about this square root thing, right? Square root of anything. What is this thing? What is this? You know, it looks like looks really bit unusual. It looks kind of nice. I mean, it looks like complicated in some sense, because you know, square root of x. What is this square root actually means? Well, square root is actually same thing as half power. That's all that is. That's all that is. Half power. Whatever inside to the half power. That's what square root means. So, you know, square root of x is the same thing as x to the half power. So, I mean, you can write it like that, but you can write it like using the square root, and it looks fancier and looks nicer in some way, right? So that's all that is. That's square root. So how do we use this? How do we use this to solve quadratic equation? So let's try a couple of examples. Oops, I'm gonna change the color. Solve. Let's say x squared equal 5. Oh, it's too easy, right? What's the answer? According to this, answer should be what? X equal square root of 5 and x equal negative square root of 5. Now, just one more thing. This we shouldn't have negative inside the square root. We shouldn't have negative inside square root. So, you know, this thing cannot be a negative number. I mean, that's what they have this condition right there. Why do we need this condition? Because this p must be a positive, or it can be equal to 0. So it's okay to have square root of 0, but it's not okay to have square root of negative 5, right? Negative number is out. I mean, you know, whenever that we hear something like that, you should at least think about why not. I mean, what happens when we have negative inside the square root? I mean, we're done with this question. This is the solution. That's it. But I guess if I put side note, what is negative square root of 5? What is this? Well, if you take couple more math course, then you will come across a situation like that. Then you will be introduced to a very charming mathematical concept called imaginary number. It just my personal opinion, I think it's a beautiful number. I mean, you may disagree. It opens up the whole new door in mathematical world, this imaginary number. So up until the discovery or introduction of this imaginary number, it was closed door. When we get to the front of the door, mathematicians has to turn around and went back to where he or she came from. But because of this imaginary number, we can actually open that door, can enter into a different level of mathematical world. It's beautiful. They can do a lot of funky stuff with this help of this imaginary number. So I hope that some of you may get to enjoy imaginary number later, but not for now. So for now, we'll just happy with the fact that p should be greater or equal to 0. If it's not, then we'll say, oh, we shouldn't, right? That's what we have for now. But later on will be much interesting. But not in this course though, right? All right. Next example. Let's say we have x minus 3 square equal 25. Okay. Now, see, whenever that you have this square right here, let's check the previous case. We have square right there. So whatever this x was equal to square root of the other side, right? The other side went right in, right? So if we apply the same concept, then can we say this, whatever this, which is x minus 3, must be equal to square root of 25, and also x minus 3 should be equal to negative square root of 25, just like that. Can we do that? I mean, if we follow the same principle that we applied in here, that should work, and it does, right? There's nothing illegal about this. This is all legal move. All right. Well, of course we are not done. Now let's simplify this a little bit further. This x equal, I'm going to move this negative 3 to the other side, becomes plus 3 plus square root of 25. Now, but what's 25? Well, 25 is 5 square, right? 25 is 5 square. And remember what I told you what this square root really means? Square root really means half power, right? Half power. So, what do we do when we have exponent over exponent? This must be a good side note moment. Let me give a side note. Let's say you have x to the square to the 5th power. What do we do with these two? Well, should we add or should we multiply? Now, if you remember this correctly, we should multiply. So this should be 10. Oh, when do we add then? Well, that's when you actually have square root of 2, x to the square times x to the 5. same base, different exponent. What do we do with this? Then you add, this becomes 7. So when we have the, did I say square root of 7 or x to the 7, right? So when we have x squared to the 5th power, exponent over exponent, we multiply these two, become 10. But when we multiply like this, then we add these two. So, let's take a look at this one right here. Let me continue it in here. So x equals 3 plus, we have 2 and square root, the 1/2 power. What do we do with this? We multiply. So 5 to the square times 1/2, cancel, becomes 1. So this is just 3 plus 5, which is just 8. One of our answer. Right? One of our answer. Okay. So it's safe to say square root of x squared. What happened to the square and the square root? Because square root means half power. They will actually cancel out. Becomes just x. Right? You can think of it as another side note. Okay, let's do this one. So that's x equals 3 minus 5 squared 1/2. So this must be 3 minus 5, so minus 2. Another answer. So answer for this question, x should be -2 or x should be 8. That's our answer. Right? Okay. We'll continue the second half in a separate video.